All right, fantastic. Okay, so just to give you a little preview, so next week is the Engineering Career Expo, I believe on Tuesday and Wednesday. So what we're going to do is I'm going to preview a little activity. So we're going to do an activity in class on Monday related to this article from The Atlantic that we're going to talk about here in a minute. You guys will read that over the weekend and then come and we'll have answer a couple of questions about that in groups on Monday. Wednesday, I know some of y'all might be at Career Expo. That's totally fine. We're going to start our first group project on Wednesday. So I will introduce the project, and you guys will have the class period to work on it. Again, you'll work in your kind of table-based groups, and we'll arrange that as necessary for people who are like two to a table type things. So you'll have Wednesday to do that. If you're not here Wednesday because you're at Expo or whatever, that's fine. Please do coordinate with the rest of your group, because we'll start having the presentations on next Friday for that. And I'll give you more details on what I'm expecting for that next week. So anyway, that's what's going on over the next couple of days here. But today, let's talk about what the energy transition actually means. Question back there. So the project, so the deliverable for the project is simply going to be a presentation. There's nothing written that you have to do. You're just going to present a few slides. Question? Yeah, I'll give you a little more detail on Monday about it. Okay, any other logistical questions? No. Okay, cool. All right. So I think I showed this slide on Wednesday, but I'm going to show it again. I've got a series of slides here that kind of illustrate what's been going on in general in terms of energy and energy transition over the past couple of decades. So when you look at primary energy consumption in the United States, going back to 1950, petroleum has been and continues to be the most used energy source. And remember, when we're talking about energy consumption, it's electricity, but also transportation, heat, and stuff like that. So obviously, most of us are still using gasoline to power our cars. There's other uses of petroleum. Natural gas has really increased a lot recently. That's the predominant means of generating electricity in the country right now. And the renewables are really down here, and they have been increasing a lot, but they are still a very small portion of primary energy consumption. It's really oil and natural gas. And really what's happened with coal is that the reduction in the use of coal has really corresponded to the increase in the use of natural gas. So that's kind of what's been going on. Now, along with that, though, there is also another interesting phenomenon where fossil fuel demand in the United States across various industrial sectors actually appears to have peaked sometime in the last 10 to 20 years and has been falling ever since then. So, for example, when you look at transportation, use of, demand for fossil fuels, it's been falling. Electricity demand for fossil fuels also falling. And some of this is driven by increases in efficiency, like we talked about. But some of it is also being driven by alternatives to fossil fuels. So that's kind of an interesting thing to consider. Obviously, this is a short time series. It only goes back to 2000. But this is an interesting phenomenon. And again, this is just in the United States. Along with that, the United States right now is a net exporter of crude oil. Okay, now I want to make a point that net exporter of crude oil does not equal energy independent. Okay, and in fact, based on a lot of the things we've been talking about, there really is, I'm going to say something a little controversial here. There's no such thing as energy independence, okay? Even if we completely go to renewable energy generation, we're not importing oil or gas from anywhere, we're not exporting oil or gas, the solar panels, they're probably made in China. The batteries that you need on the grid to make up for intermittency, the lithium is probably coming from Chile, okay? There's no such thing, and just the way the global economy works, there's no such thing as energy independence. And along with that, the US exports more oil than we import, but we still import a fair amount of oil. It's just this crazy worldwide, global supply chain thing. So, but it's an interesting thing to think about. But suffice to say, the U.S. has seen a rapid increase in oil production over the past 10 years, mainly driven by the expansion of development of unconventional resources. So it's really changed the global energy picture. At the same time, when you look at natural gas prices and commodity prices in general, I don't have oil price here, but it's, the price of oil has been kind of stagnant at about $80 a barrel for the past couple of years as well. Natural gas prices, they spiked in 2022, driven partly because of Russia invading Ukraine, but there are also some systematic and structural things in the natural gas supply system that I'll talk about in a little bit that were going on that contributed to this. But the price of natural gas over the past year or so has also been quite low. And this goes a little bit along with the reduction in industrial demand for fossil fuels. So that's kind of an interesting thing. And then the last thing is looking at energy storage. So I talked about batteries on the electric grid. When you look at grid scale storage, that has really been ramping up tremendously over the past 3 or 4 years. And in fact, the EIA's annual energy outlook from 2023, they made a prediction that is this blue curve here, that by 2030, we have about 30 gigawatts of storage on the grid. Well, now it looks like we'll probably meet that well ahead of schedule. So there's more storage coming online than people would have suspected even a year ago. So there's some very interesting things here when you think about potentially, at least in the US, fossil fuel demand may already have peaked. We are seeing changes in the way that we're getting our energy and our electricity. And so, the energy transition is really underway already, whether or not we realize it. And it's going to accelerate going forward. Now, does this mean, and I talked about this Wednesday, that there is not going to be any demand for fossil fuels in the future? And the answer is no. We're still projecting that we're going to be using those for energy. And this is on a global scale. You might see a large reduction here in the US, but globally, we're still going to be using fossil fuels for a lot of stuff in 2050. And we need to think about, the ways of abating the carbon emissions associated with that. Okay, so that's kind of setting the stage for what we are going to be talking about. So this is a very nice article. It was published in The Atlantic 3 years ago now. It doesn't seem like that long, but 3 years ago. And it's a really good summation of the complications that come along with the energy transition. It's called Why the Energy Transition Will Be So Complicated. I have put a PDF of this article up on Canvas, and I want you to read it over the weekend, and then we'll do an activity in class on Monday. But I'm going to kind of talk through the main ideas here, just so you get some understanding of what's going on. So this article starts out by describing a controversy that the North Face, the outdoor clothing company, got into. Basically, what happened was an oil field service company asked the North Face to make some swag for their employees to get at their holiday party. which was going to have the logo of the company on it and stuff like that. And the North Face said, no, you know what? We are committed to sustainability. We are not going to do this for you guys because you're in the oil and gas business. So, hands off. Sorry, not sorry. And, I think, I don't remember exactly how it ended up, if they got sued or something, but it was a bit of a kerfuffle that was, publicized. And, the article goes into, some of the issues associated with that. Obviously, a lot of clothing contains synthetic materials, right? Like polyester and stuff like that, which is made from oil. Okay, so it's really hard to get away from some of these issues. Okay, so if you go to the website of the North Face, you can see their commitments here. And they're talking about reducing waste. They're talking about reducing greenhouse gas emissions over their whole supply chain, reducing single-use plastic packaging, and using responsibly sourced or regeneratively grown materials for their apparel. Okay, that's all great. One note I want to make here, and so obviously they're committed to this. It's right there on their website. One thing I want to note here, they talk about scope 1 and 2 emissions. You may have heard these terms before. I'm going to tell you a little bit about what they are. So this is just a little bit of a side note, but it's important for thinking about decarbonization strategies. So scope 1 emissions are going to be direct emissions from stuff that you own. So I was on an advisory committee for a student organization a couple of years ago that was looking at the CO2 emissions from the University of Texas, okay? And so a good example of scope 1 emissions from UT is, university-owned vehicles driving around, burning gasoline, stuff like that. The emissions associated with the power plant. This is just, things from what you own or you directly control. Scope 2 is going to be indirect emissions from things that you purchase. So basically the emissions associated with generating the electricity that you are using. That's going to be your scope 2 emissions. So these ones are very easy to control because you can reduce emissions from stuff that you own, right? By, electrifying it or things like that. Scope 2 is a little more difficult because let's say the university wanted to go to completely have an electric vehicle fleet. Well, then you have to start thinking about where's that electricity coming from, right? If it's coming from the power plant over there, obviously we're burning natural gas for that. If it's connected to the grid, there's a mixture of natural gas and coal and renewables on there, so you have to think about that as well. So that's a little bit less in your control, but you can kind of do your best to try to reduce that as much as possible. Scope 3 emissions are not discussed in their corporate strategy here. And a lot of companies actually choose not to address scope 3 emissions because it's basically impossible to control, or it's very difficult to control. These are all other emissions, but specifically for companies that produce products, they are going to be emissions associated with the use and disposal of those products, okay? A good example of thinking about this is, if I'm an oil and gas company, the scope 3 emissions are going to be people burning the oil or gas that I'm producing. And there's just no way of mitigating, right? That's just how it is. And excuse me. And even for other types of companies, it's very difficult to control what happens with the products after the consumer uses them. So you can try to design them as much as possible so that the use of those products does not result in excessive emissions, but it's a tricky one. So anyway, when you're looking at corporate sustainability strategies, you'll see scope 1 and 2 a lot, not often scope 3. Okay. It's interesting to think about what the scope 3 emissions from the University of Texas would be, because the product that we produce is you guys, right? So, I don't know. Okay, so anyway, so that's, the North Face, they're committed to sustainability, committed to reducing waste, reducing greenhouse gas emissions. Okay, so the company that wanted to work with them was this company called Innovex. They are a downhole tool manufacturer based out of Houston. And after they were told by the North Face that they would not make company branded apparel for them, the CEO wrote to the CEO of the North Face, basically saying, look, there's a lot of kind of run up here. Low cost, reliable energy is critical to enable humans to flourish. Yes, I wouldn't quibble with that. Oil and natural gas are, produce low cost and reliable energy. That's true as well. And so, basically, he was upset about this, but what he gets to the point down here is that, the clothing that the North Face makes, again, is made a lot from synthetic materials that come from oil and gas. And so it's not as easy as just saying, well, we're not producing oil and gas, and so everything's good. We're going to be sustainable and all this good stuff. It's a lot more complicated than that. And, when you think more broadly about energy transition and decarbonization, it's important to consider kind of the global aspects of this whole thing. So, what's going to happen to global supply chains if we, really upend the way that we get energy? New things are going to happen. New problems might come to light. The other thing is, as we see this real upswing in commitments for net zero by 2050 and all this stuff. How does our relying on stuff that comes from oil and gas, plastics, things like that, how does that square with these net zero commitments? How can we make sure that we're mitigating the emissions associated with that? It's not a simple question. For you guys, I hope you think about this as it's an engineering problem, right? This is a system that needs technical solutions, needs to be optimized. Okay, it's I'll probably talk in Unit 2 about carbon management a little bit, but when you think about the whole process of removing carbon from the atmosphere and permanently storing or sequestering it or using it somewhere else, that's a big, complicated system with a lot of engineering challenges. And I think there's a lot of opportunities for you all in the future to think about that. Okay. Another thing that I want to point out here, talking about global supply chains. Okay, so in the early winter of 2022, and actually going back into late 2021, this is even before the invasion of Ukraine, there was an energy crisis in Europe where the price of natural gas spiked. This is the European benchmark natural gas price. It's in euros per megawatt hour, so don't worry about the units too much. But you can see that going back into 2019, 2020, it was relatively low, below about 25 euros per megawatt hour, and then you had a huge increase all of a sudden. And there were a number of causes for this. So in Europe during the winter, they typically see increased demand for gas because it's a lot of what they use for heating is natural gas. But this is much more than you would see in a typical winter. So there were a number of causes. So number one is just the typical increased demand that you have in winter. But there was a confluence of other factors here, including that it was not particularly windy that year or that time of year in Europe. So they weren't getting as much wind production as they normally would. A lot of countries were in the process of phasing out coal-fired power plants, nuclear power plants, and that sort of thing. And so if you're left with natural gas and renewables, and your renewables aren't keeping up, then all you're really left with is natural gas. That's going to cause a price spike because of the increased demand. There was still some residual COVID effects. They didn't do as much maintenance on the power plants as they should have done, or on other oil and gas infrastructure. So there were some problems there. And then overall, natural gas production in Europe has been declining over the past decade or so, partly on purpose, driven by needs for more sustainable forms of energy, but also mainly because a lot of the natural gas fields are getting depleted. They used to get a lot of gas from the North Sea, for example, but the fields in the North Sea have become depleted and they're just not producing as much as they used to. So that's just the reality of fossil fuel production, that you're always on that decline curve, right? You always have to be looking for the next well to drill. And so, there was a lot of commentary at the time about, oh, this is all because we're transitioning to renewable energy. Well, it's not really that simple. Okay, so yes, reducing coal power generation and nuclear power generation, that was deliberate, and that was a top-down thing. Although you could argue that reducing the amount of nuclear power available maybe is not a very smart move if you want to have more sustainable energy, but we'll talk about that later. Some amount of the decrease in gas production also driven by policy, like I just described. But you also had a lot of other things coming together. But the question here is that is this sort of commodity price shock going to be a feature of the energy transition, or was this just a one-off? So you have to be very careful about how you're planning things out. Okay. When we look at previous energy transitions, there's been several of them over the past 200, 250 years. And I think I showed this figure before. But when you go back to 1800, world energy consumption was 95, 96% biomass, so burning wood and that sort of thing. Coal really took over, and by the early 1900s, coal was the dominant form of energy being used, and it displaced biomass. People were not burning wood and sticks and stuff, they were burning coal. And that has a number of advantages, okay? So coal is much more energy dense than wood, and so you get a lot more energy production from it. Since about the mid-1900s, you can see that oil really came along, and oil and gas together really displaced a lot of that demand for coal. So you had coal came and displaced biomass. Oil and gas came and displaced coal. So that was a feature of previous energy transitions where new sources of energy displaced old ones, okay? In the future, depending on who you ask, there are some people who advocate for renewables to completely displace oil and gas. There are other people who advocate for renewables to be additive on top of oil and gas because we'll have increased energy demand in the future and we'll need that additional capacity. And so, you have to think about what's the end result there? Is this all doable? Is this something that we can make happen? Question, Tommy? So that's a good question. So I guess to rephrase that, are changes in demand visible in this graph? And I don't remember if I have a figure that shows energy demand. So I mean, let's assume that it's been going up since 1800, which I think is probably fair. Then yeah, so this is looking at percentage, but also if you remove that energy demand. Well, actually, let me go back to this figure. Yeah, this one. So this is energy consumption in the U.S. going back to 1950. The renewable component of this looks very small because petroleum and natural gas are so far up there. And I think that this figure maybe exaggerates a little bit of renewables because if you had this be total energy, the y-axis would be so much larger than it would be on the, for earlier times. Does that make sense? Yeah. Okay. Right. So, what's the, what is the future energy mix that we wish to see, and how do we work towards that? And, I'm kind of agnostic on that point. I think, my personal opinion is that we need to meet the energy demands of the world. And we need to do that in as sustainable, and by sustainable, I'm kind of talking mainly about carbon emissions, but there's other aspects of that. We need to do that in the most decarbonized way possible. There are a number of ways to get there, and I'm not going to tell you what the right answer is because I don't know. But that's really the goal that we need to be doing. And so does that involve, having renewables and other types of energy generation be additive on top of fossil fuels? Does it mean doing away with fossil fuels completely? I don't know. You could do it either way. Okay, but it's going to have to be one of those. Question back here. Yeah, so the question is, do we have enough lithium on Earth to give everybody who wants one an electric car? The answer is yes. This was an issue that came up about a year and a half ago, and I don't remember if I showed you guys this figure or I just told you about it, but the price of lithium spiked about 2 years ago because there were concerns about supply shortages and that sort of thing. But then a bunch of people looked at worldwide lithium resources and came to the conclusion that no, actually, even if everybody drives a Tesla Model 3 with the amount of lithium that it needs in its battery, we have plenty of lithium. So that concern actually has gone away. Now, that's not to say that there are other materials that we should be concerned about. I think, I keep coming back to cobalt, poor old cobalt. But, that's one where, do we want to just keep using that and, and kind of scale up the production, or mining for cobalt? I don't, probably not the way we're doing it right now, but is there other things that we can substitute for that? That's why, so getting back to the lithium, okay, so now you've got me down the rabbit hole here, but so going back to lithium, so in Abby's presentation this morning, she mentioned sodium batteries, and a lot of people started looking at sodium and other types of cation batteries a couple of years ago when we were worried about the lithium supply, because sodium and calcium and magnesium to some extent are abundant in seawater. And so you could think of having some large scale supply chain where like you're desalinating seawater, and then the stuff that comes out of it, the sodium, you can use it to make batteries and everybody would be happy. I think that from what I've been reading, a lot of the interest in alternative cations for batteries has kind of died down, although it could be, I could just not be aware of it, but I haven't seen as much chatter about it. I think that that's related to this new realization that lithium supply is not as constrained as we thought it was. Okay, but yes, to your point, you have to think about where all these materials are going to come from. There's, I probably spend too much time on social media. In fact, I know I do, but I'm always scrolling through and I see all these cool graphs. I'm like, oh, I want to show this in class. I saw one that, it comes up occasionally. Maybe the next time I see it, I'll make sure to download it. But it's looking at the amount of material that is mined for a fossil fuel-based economy versus a completely renewable-based economy. And actually, in the case of fossil fuels, you actually are mining more raw materials than you are with a completely renewable economy. A lot of that is just the oil and gas that you're producing, but there's a lot of other stuff that goes into that. All of the, the steel and the stuff you need for, the pipelines and the downhole infrastructure. So there's, that aspect also to consider. Okay, good questions. All right. Let's talk a little bit about, there's this concept called the just transition. And the just transition means doing the energy transition in such a way that you don't harm anybody. Okay. Part of that is, here in Texas, there is, rightly so, concern about if we phase out of fossil fuels, what's going to happen to all of our wonderful, educated workforce who works in the oil and gas industry. And so, that's something you have to think about. But another aspect of that is who's responsible for really driving the energy transition? Who should it be? Okay, so if we look at total greenhouse gas emissions around the world, these are the figures I'm going to show you are from 2009, but they're still generalizable to today. So back then it was 34 gigatons of CO2 equivalent per person per year. Okay, so that's worldwide average. Now, when you break this down a little further, probably not surprisingly, North America, we have the highest greenhouse gas emissions per capita out of the rest of the world. Sub-Saharan Africa is quite a bit lower, okay? Asia also is quite a bit lower. They have a lot more people than we do. You can subdivide this even further by country. So, Australia, the US, Canada, we're kind of over here pretty high. Some of the countries in the Middle East are also quite high. Some of these spikes correspond to countries that have a lot of natural gas production. So that's why Qatar and the UAE are so high, because natural gas production has a lot of CO2 emissions associated with it. Not like Scope 3 stuff from actually combusting it, but like methane leaks and that sort of thing. We'll have a short unit on that. So, same thing, Trinidad and Tobago, they have big natural gas fields down there. So there's a lot of emissions associated with that. But there's a lot of countries that have not very much greenhouse gas emissions per person. And if you integrate the total CO2 emitted per person going back to 1880, you can see that the United States, the UK, and Germany are really the top three contributors to CO2 emitted over that period, okay? So when you think about driving the energy transition, paying for the energy transition, and making sure that we don't do harm in the course of the energy transition, there's a strong argument to be made that it falls on us in the United States because we have emitted so much more CO2 than, India, for example. Do we have the right to go and tell India, hey, you guys are emitting too much CO2 when we have emitted so much ourselves? So there's a responsibility that you have to think about in shepherding and stewarding this thing through. Okay, but at the same time, even switching to burning natural gas for cooking has a tremendous increase in the quality of life of people. So in a lot of developing countries, particularly sub-Saharan Africa, people are still cooking indoors with like wood or other waste products, kerosene, and there's a large indoor air quality problem associated with that. And if you switch that out to natural gas, you alleviate a lot of those indoor air quality issues. And I showed you earlier that particulate matter is a serious health concern in a lot of places. And so you're already doing people a favor by making them use natural gas for cooking. There's also some geopolitical aspects here. So Nigeria is I think it's the most populous country in Africa, 200 million people. 70% of its budget relies on oil and gas sales. Okay, so if we stop using oil and gas, what is going to happen to countries like Nigeria, Kazakhstan, or Azerbaijan Iran, that are so dependent on oil and gas sales for their economy? We need to think about that as well. And so there's a quote in that Atlantic article from the energy minister of Senegal that, if you stop investing in oil and gas development, she said, it's like removing the ladder and asking us to jump or fly, right? So, it's not really the right thing to do. You have to think very carefully about how you go about having a transition to less carbon intensive forms of energy. Some of this is, a lot of this is an engineering problem. A lot of it is also kind of a policy problem and just, thinking about the, human impact of what we do. I think, as engineers, it's important for us to remember the, how what we do affects society and affects people around us and around the world. So just to sum up here, we clearly need new technologies. And I think that that's kind of the lowest hanging fruit. And over the course of the semester, I hope to give you guys some understanding of where we are with technologies and where some of the challenges and opportunities are in the future. And also, like I was just saying, what we do as engineers, we're not operating in a vacuum. There are, social, economic, and policy implications that we need to think about and be aware of as well. Okay, so I'm going to leave it there for today. And I hope you all have a nice weekend, and we'll come back Mondays. Please do read that Atlantic article, and we'll come back Monday for an activity.